Now the equation y prime plus p of t y equals 0 does have solution y equals e to the negative integral p of t dt. However, you notice that there's no integration constant. Would it be y equals e to the negative integral p of t dt plus c? Well, that wouldn't work. If you added a constant onto this, the constant would appear on the y term, but on the y prime term, the constant would be would become 0 when you take the derivative, and the equation would not be solved. So what about this integration constant idea? The idea that when you solve a first order equation, you have an arbitrary constant. Let's observe. If y of t is a solution to this equation, then so is a times y of t, where a is any constant. And to see this, we can just let instead of substituting just y, let's substitute a times y of t. So a y of t prime plus p of t times y, which would be p of t times a y of t, should then equal 0. Well, if we take the derivative of a y of t, we get a y prime of t, and if we rearrange this, we can get it into the form a times p of t y of t equals 0. Then a being a constant, we can simply divide it out. If we divide through by a, we get y prime plus p of t y equals 0, which is our original equation. And if y is a solution to this equation, then so was a times the y function. Now, in going from this step to this step, I didn't put the t dependence in. I wrote just y prime and y instead of y prime of t and y of t, but that's legitimate, and that puts the equation back into the original form to show the equality. Now, the square root of t y prime plus y equals 0 was previously put into the form of a linear homogeneous equation. It had solution y of t equals e to the negative 2 square root of t. So what would the general solution be? General solution, well, if y of t is a solution to an equation of this form, then so is a y of t, so the general solution would be a e to the negative 2 square root of t. This would allow us to put an initial condition or some condition on our solution and adjust the constant a to fit the condition. Similarly, this equation had solution y equals t. It's of the form y prime plus p of t y equals 0, if we simply rearrange it. So its general solution is y of t equals a times this function, y of t equals a times t.